Hello, this is Mr. Bainey, and the lesson here is 10.2 Algebraic Representations of Dilations. In the last lesson, 10.1, I described what dilations are, how to think about them, and also how to find scale factors. So I suggest you go look at that lesson if you're still a little bit shaky on understanding how dilations work. This lesson is more to um, look a little bit deeper into how we write algebraic rules and and also how we graph and describe dilations. So the standard for this lesson is 8.G.3 up in the top right, and the essential question: how can you describe the effect of a dilation on coordinates using an algebraic representation? So a dilation, remember, is when we take a shape, a pre-image, and make it bigger or smaller, right? We call that an enlargement or a reduction. And one of the new things here that we're going to see is this algebraic rule, or they also call it algebraic representation. It is x comma y transforms into kx comma ky, and k is the scale factor. Okay, it tells you right here, scale factor k. Let's try out this Explorer right here, and we're going to fill out this table. So we have the point 2 comma 2 that was filled out for us. So if I look at my graph on the right, 2 comma 2 is right here. Okay, I'm gonna make a dot where the points that we're using are. Now the image, if the pre-image is x comma y, the image says 3x comma 3y. So this is actually the rule that they're giving us. They're giving us this rule. Now 3x, what does that mean? If the 3 is next to it, it's multiplying. So we're just doing 3 times whatever x is. And same thing for 3y. Whatever y is, we're going to take 3 times y. So the pre-image point, 2 comma 2, I'm just multiplying them by 3. So that times 3 is 6, and the other 2 times 3 is 6. So I get the point 6 comma 6. So I'm going to plot these as I go. The next one I'm going to look at on the pre-image is 2 comma negative 1. Let's multiply those by 3. I'm going to get 6 comma negative 3. Right? Multiply 2 by 3 and then negative 1 times 3. And so 6 comma negative 3 is going to be down here. Now the next one is 1 comma negative 1. Again, I'm making the dots on the right side just to make sure I keep track of what I'm using already. Multiply 1 times 3 and negative 1 times 3, and I get this. So that is going to go right. 3 and negative 3 is right here. The next one is 1 comma negative 2 and 1 comma negative 2. Both of those times 3 is going to give us 3 comma negative 6. So 3 comma negative 6 goes way down here at the bottom. Our next pre-image point is negative 2 and negative 2. Multiply those by 3, and I get negative 6 and negative 6, which will go right here at the bottom left. Our next point, negative 2 comma 1. Multiply those by 3, and I get negative 6 comma 3. So that goes here in the top left. Next point is negative 1 comma positive 1. Multiply those by 3, and I get negative 3 comma positive 3. And negative 3 positive 3 is on the graph now. And one more point, negative 1 comma 2. Times 3, each of those is negative 3 comma 6. And assuming that I did all of this correctly just now, and then if I also connect these the right way, then you're going to see, hopefully, an enlargement, right? This thing looks really, really big. I just applied the same exact rule to every single point. It was a lot of points, but dilations are very consistent in that you do the same thing all the time. So check this out. We got the same shape. The blue shape and the red shape are the exact same shape. I'm sorry, not exact. I shouldn't say that, but they are the same shape, but they are a different size. The scale factor in this case is 3, right? Or we can say k equals 3 because k is scale factor. And the scale factor is just what are we multiplying everything by? And we already did parts C and D. That's done. So when we do a reduction, I'm not going to do this whole explore activity 2, but if you would like to give it a try, I can get you started. So I'm going to take one of the coordinates of this arrow looking figure here. Let's take a look at, I'll plot the point there. This is the point 4, 2. And our rule that you see right above, x, y is going to transform into 1/2 x, 1/2 y. So this is still multiplication, but you can change it to division because now it's a fraction. 1/2 times x is the same as saying, oh, let's take 1/2 of x. So can I take 1/2 of 4? What would that be? Or you can think of it as x divided by 2, which would do the exact same thing, right? So if I do either half of the 4 or divide it by, right, or take 4 divided by 2, then I'm going to get 2. The 1/2 y does the same thing. So my y value is 2, and that would become a 1 if I take half of it. So that would go at 2, 1 right here where I put the red point on the right side. And you can continue to do this, and you should get an arrow figure that is smaller than what you started with on that right side, okay? And lastly, let's take a look at actually doing a dilation, right? With either a description or with a rule that's given to us. The your turn at the bottom is giving us a rule. I'm sorry, it's giving us a description. It's asking us to write the rule. So we have the pre-image on the right side. And what I would suggest doing is if you have a hard time with figuring out how the different ways you can work with the scale factor, I would suggest just writing out the points. So I'm going to do it over here all the way on the right side. I have a point X, a point Y, and a point Z. I'm just going to write down the coordinates for all of them. So X is 3, 3, it looks like. Y is 9, 9. And Z is 3, 9. And you know what, let's move this actually. Move it way over here. Okay. We're going to transform these. The scale factor is 1/3. So that means we're multiplying these by 1/3. You can either take 1/3 of all these numbers here, or you can divide it by 3. Those are all the same thing. So multiplying by 1/3 for x is going to give us x prime is 1, 1, right? Dividing by 3, same thing. Y prime means I'm going to take 9, 9 and divide each of those by 3, and I get 3, 3. And then z prime, 3, 9 will become 1, 3. So if I did all of those. And then I'm also going to make sure I label my points, right? You want to get in the habit of doing that if you know what the image points are. And I get this shape. So first, is this an enlargement or a reduction? All right. Make sure that we do have the same shape. We have the right angle that's right here at point Z and the right angle that's here at Z prime. Okay, the angles stay the same. All the angles stay the same, even though the shape got smaller. We're going to go ahead and write the rule also. All right, remember, all algebraic rules start with x comma y. All of them do, and the arrow. So the way we write the rule for dilations is we have kx and ky. K is our scale factor. So that means that we're going to have 1/3 x, comma, 1/3 y. And that's all you have to do for the rule. Okay. The description is right here. So understand how the description looks like compared to the rule and how that affects the graph that's there on the right side. Okay, and that's it for this lesson. Thank you so much for watching. Have a wonderful day.